So, another probability question. The probability that a biased dice will land on a 4 is 0.2. Pam is going to roll the dice 200 times, work out an estimate for the number of times the dice will land on a 4. Okay, a number of different ways we can think about this, so let's get going. So we know, first of all, that 0.2, we can think of that as a fraction as 2 out of 10. So another way of thinking of that is, rather than the probability of 0.2, we can think of 2 out of 10 to every 10 times she will get a 4. But I want to know how many times she will get it out of 200 times. So I'm going to make an equivalent fraction. 2 over 10 equals something over 200. Now, to equivalent fractions, I have multiplied the bottom of that fraction by 20 to get 10 to 200 is times by 20, and I'll have to multiply the top by 20 because to keep a fraction equivalent I need to multiply top and bottom by the same thing. 2 times 20 is 40. So one way of answering that question is by using equivalent fractions and say we would expect to land 40. Another way of doing that question is just to use the relationship that expected number equals probability times the number of trials. I do apologise for my poor handwriting here, but it's quite tricky actually getting used to this. So the probability of 0.2 times 200. Now we know that 2 times 200 is 400, but 0.2 is a tenth of that, so 0.2 times 200 will be 40. So that's another way of doing that question. Either way, using the idea of over here, when we use the idea of equivalent fractions, or just using the expected number is the probability times the number of trials. Right, let's have a look at the second part. The probability that a biased dice will land on a 6 is 0.4. So that's quite a biased dice. Ted rolls the biased dice once. Work out the probability that the dice will land on either a 4 or a 6. Oh, it's the same biased dice as the first part of the question. I was confused for a moment there. So probability lands on a 4 or a 6. Well, it can't land on both at the same time. So there are some possibilities here. You could get a 4, or we could get a 6, or everything else. 1, 2, 3, and 5. Okay, now probability of 4, we're told in the first part, is 0.2, and the probability to get a 6 is 0.4. Now, or a 6 means we can go down there or there. So the chance of going down there or there, 2 out of 10 times we go along there, 4 out of 10 times we go along there. So 6 out of every 10, or 0.2 plus 0.4 equals 0.6. Okay. Now, when you hear the word or in a probability question, that generally means that you've got two possibilities, either of which could happen. And so there you add probabilities together.
Where's Daddy? Oh no, not tonight. I guess it's the weekend.